Today we'll start chapter number 11 in EC first year, thermal properties of matter. Today I am attempting different new, that is I am using projector to display questions. In the last topic, that is in gravitation, we have taken synopsis in detail but not questions. Today I will try to attempt, in this topic I will try to attempt to solve some questions by displaying 4 options, right? Okay, I don't want to explain what is the meaning of the heading. Directly I will move to the points which are necessary for NEET, JEE and KCET. Here, thermal means something related to heat. As you know, heat is measured in terms of temperature. You know what is a temperature? It is a fundamental physical quantity and is measured in terms of Kelvin in a such system. You know, this temperature measures hotness or coldness of a body. It tells us degree of hotness or coldness of a body. And second one, how it flows. What is the natural direction of flow of heat? You know, always heat flows from a body at a higher temperature to a body at lower temperature, right? And third point, when do we say two bodies are in thermal equilibrium? That is, we can say two bodies are at thermal equilibrium when no heat flows from one body to another body. That is, whenever we take two bodies, say it is a first body, it is a second body. Whenever we kept in thermal contact, if there is no flow of heat energy from one body to another body, then we can say they are at thermal equilibrium. But when this happens, when there is no flow of heat from one body to another body, answer, when they are at same temperature. Okay. Next, one question arises, how come we know the body is at higher temperature and this body, another body is at lower temperature? So for that we have a simple experiment here. That is, whenever we touch a body, then if we receive heat energy from that body, then we can say as compared to our body, that is hand, this body is hot. Means if you receive heat energy from any body, then that body is said to be at higher temperature. When we touch another body, if we lose heat energy, if our body is losing heat energy, then we can say that body is cold. That is when we receive heat energy, then that body is hot. When we are losing heat energy, then that body is said to be cold. Okay. So next point, that is what we say when the state of a body does not change. In another way, whatever I said in the previous PPT. So same thing I can say here. Whenever we give heat energy, after giving heat energy, if the state of a body does not change, that is, a solid remains solid or liquid remains liquid after giving heat energy. Then see, if the temperature of a body rises, that is, whenever a body absorbs heat energy, its temperature rises. Similarly, when a body loses heat energy, then its temperature decreases. That is, say, this is a body. When it absorbs heat energy, then its temperature increases. Similarly, this is a body. When it loses heat energy, then its temperature decreases. That is the meaning here. That is, whenever a body loses heat energy, temperature decreases. But question arises, inside the body, who will decide the temperature? So for that, as we have studied earlier, that is, in the matter, every atom or molecule are vibrating about their mean position. So these vibrations have a kinetic energy. The average kinetic energy of the atom or average kinetic energy of a molecule will decide the temperature. That is, average kinetic energy of the molecule is a temperature. That is, according to kinetic theory of gases, temperature is a macroscopic physical quantity. Is a measure of average translational kinetic energy of a molecule. You know, the average translational kinetic energy of a molecule. You know, molecules are invisible, they are very small. Hence, I can say microscopic physical quantity. But temperature we can see, means we can feel. Therefore, it is called as a macroscopic physical quantity. Right? And although whenever I said in previous case, whenever we provide heat energy, temperature goes on increases. But question arises, what is the limit of increase in the temperature? In what temperature we can increase? So if it goes on loses heat energy, temperature decreases. Till what limit temperature decreases is the question. Right? So according to this, theoretically there is no limit. Without limit we can increase, and without limit we can decrease. But practically, what theoretically we have taken, low temperature is taken as 0 of the Kelvin scale. So till Kelvin, in Kelvin scale, 0 Kelvin is the lower limit. We have taken 0 Kelvin is the lower limit to decrease the temperature. Okay. So highest possible temperature achieved in our laboratory is 10 to the power plus 8 Kelvin, where lowest possible achieved temperature is 10 to the power minus 8 Kelvin. Right? And temperature of the sun, core of the sun is 10 to the power 7 Kelvin, while temperature of surface of the sun is 6000 Kelvin. And you know what is the normal temperature of a human being? That is 37 degrees Celsius or 98.6 degree Fahrenheit. So this is the basic of our temperature. But these are all known facts for you. No need to explain here. Directly I will move to next, that is a scales of temperature. You know, today we have to measure the temperature. The measurement of temperature is called as thermometry. 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 Thermometry means measurement of temperature is called as thermometry. And to measure the temperature, we have different scales like Fahrenheit scale, Celsius scale, and Kelvin scale. To measure this, for all scales we have two limits. One is called lower limit, that is lower fixed point. Another is upper fixed point. Here, lower fixed point. Lower fixed point. That is freezing of water. The temperature at which water freezes is taken as lower fixed point at normal temperature and pressure. And the temperature at which water boils is taken as upper fixed point. For any scales, these are same. Lower fixed point and upper fixed point are same. Only difference is the number of divisions made between the upper fixed point and lower fixed point. That will differ a different scales. If you look at here, we have taken say mercury thermometer. Here for lower fixed point, level is same for all three scales, and upper fixed point is also same. Only difference is number of divisions between lower fixed point and upper fixed point. Okay, for your convenience, let's have a list. See, scale, first Celsius scale. Their symbol is degree Celsius. Their lower fixed point is taken as 0 degree Celsius and upper fixed point is taken as 100 degree Celsius. That is between lower fixed point and upper fixed point, number of divisions in the scale is 100. Similarly, Fahrenheit scale represented by degree Fahrenheit. Your lower fixed point is 32 degree Fahrenheit and upper fixed point is to 212 degree Fahrenheit. The number of divisions on the scale is 180. Whereas Reaumur scale represented by degree Reaumur and the lower fixed point is 0 degree Reaumur and upper fixed point is 80 degree Reaumur. If you look at the difference, it is 80. Then Rankine scale, degree Rankine, that is RA, is a representation. 460 Rankine is lower fixed point and 672 is the upper fixed point. The total number of divisions between upper fixed point and lower fixed point is 212. Then Kelvin scale, lower fixed point is 273.15 Kelvin and upper is 373.15 Kelvin. Between lower fixed point and upper fixed point, number of divisions are 100. Okay. See, then if you know temperature at one scale, can we get the temperature in another scale? Yes. For that we have a simple relation. That is relation between different scales. Relation between different scales. That is, here we have relation between different scales. That is a reading on any scale. I'll write here reading on different scales. Reading on different scales, reading on different scales minus lower fixed point divided by upper fixed point minus lower fixed point. You know, upper fixed point minus lower fixed point will be equal to number of divisions between upper fixed point and lower fixed point. Keep in mind. Okay. So upper fixed point minus lower fixed point. This is always remains constant. This is always remains constant. So based on this equation, you can write the relations. First I will try to write. Okay. See, first I will go for Kelvin scale. Say reading on the Celsius scale is C minus, what is the lower fixed point? 0. C minus 0 divided by the upper fixed point minus lower fixed point. Upper fixed point minus lower fixed point. 100 minus 0 is 100. I will try to write it as that is equal to, for Fahrenheit scale, how do you write for Fahrenheit scale? See, reading on the scale I will write F. minus lower fixed point is 32 divided by upper fixed point minus lower fixed point. That is 212 minus 32 is equal to 180 degree. That is 180 degree. That is also equal to, you can write for Riemann scale, Rankine scale, Kelvin scale. Please try yourself. For Riemann scale, it is R minus 0 divided by 80. Okay, right? Rankine scale, it is RA minus lower fixed point is 460 divided by 2. 672 minus 460 is 212. That is equal to Rankine scale. Then Kelvin scale. Temperature is K minus 273.15 divided by 373.15 minus 273.15 is again 200. Right? So this is the relation for different scales. Still you can simplify. That is C minus 0 is C by 100. C by, you can write yourself here. That is C divided by 100. C by 100 is equal to here F minus 32. F minus 32 divided by 180. That is equal to R minus 0 is R divided by 80. That is equal to, you can write for Rankine scale here, RA minus 460 divided by 212. That equal to, for Kelvin scale, you can write K minus 273.15 divided by 100. Okay, so this is our relation between different scales. Now, first you do one thing. First, pause the screen and copy this table. Pause the screen and copy this table. Thereafter, you can copy this. Right? Do it fast. Now come back to the questions. Before going to the questions, I have a simple question here. That is, I'll go back to this figure. See, as I said, the amount of heat energy required to raise the temperature from lower fixed point to upper fixed point on all scales remains the same. Whether it is a Celsius scale, Fahrenheit scale, Riemann scale, Rankine scale or Kelvin scale, amount of heat energy required to raise the temperature from here to here remains the same. But in case of Fahrenheit scale, when we provide heat energy, how many divisions it rises? One. In Celsius, how many divisions it rises? 100. In Kelvin, it is also 100. Based on this, if I ask you a question, whenever we provide heat energy to a body, so let's say it is a body A, here it is a body B of same size. Size remains same. Identical bodies. Same. Here H1 heat is given to rise the temperature by 1 degree Celsius. Here H2 heat is given to rise the temperature by 1 degree Fahrenheit. Then out of H1 and H2, which is high? That is, in which case more heat energy is necessary to raise the temperature in A and B is a question. For that, I take a simple example. See, from two lines of same length I will do. Here to here I will make a 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. Okay. In next case, same, in the same height, I should do 18 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18 lines. It means here, when to rise 1 degree Celsius, we have to increase, we have to raise the mercury up to this height. Here in this case, we have to raise only this much. Means we need more heat energy to raise 1 degree Celsius as compared to 1 degree Fahrenheit. Or same question can be asked in another way. Here we have two bodies. One has a temperature 1 degree Celsius, another has 1 degree Fahrenheit. Then which is hot? Which is more hot? Which is more hot? Answer: A is more hot than B. These kind of questions are common in our topic. Okay, let's start one by one. Okay, question number 1. The temperature at which centigrade and Fahrenheit scales gives same reading. It's a very common question in our topic, right? So, it means at what temperature degree Celsius as well as a Fahrenheit scales gives same reading. Okay, then I'll use a relation between Fahrenheit and degree Celsius. To obtain the relation, I'll use this. I assume both are showing the reading x divided by 100 is equal to, it is also x minus 32 by 1. Hope you can simplify. So this 0 get cancels, cross multiply. 18x equal to 10 in bracket x minus 32, or 18x is equal to 10x minus 320. If I shift here, it becomes 8x is equal to minus 320, or x equal to, I think, minus 40 is the answer. Minus 40 degree is a temperature at which centigrade scale and Fahrenheit scale shows same rate. So option number 1 is correct. Pause the screen and write down. Question number 2. The absolute zero temperature in Fahrenheit scale is. First you have to remember what do you mean by absolute zero. Absolute zero means 0 Kelvin is taken as absolute zero. We want the Fahrenheit scale. It means we need the relation between Fahrenheit and Kelvin. Fahrenheit and Kelvin. Okay. So use this. F minus 32 divided by 180 is equal to K. Here K means what we have taken, absolute zero. Absolute zero means 0 Kelvin, minus 273, better we take that much only, divided by 100. simplify this and this 0 and cross multiply. It may be 10f. Or otherwise we'll do one thing. F minus 32 by 18 is equal to minus 27.3. This 273 by 10 means 27.3. And cross multiply, you get your answer. Cross multiply to get your answer. Okay, can you do? F is equal. Simplify. Pause the screen and hit the answer. So answer is C. That is minus 460 degree Fahrenheit is the answer. Next question. See, two temperature scales A and B are related by A minus 42 by 110 is equal to B minus 72 by 220. At which temperature two scales have same temperature? I think this is very similar to our first question. Do one thing. A is taken as x and B is taken as x. Substitute and simplify, get your answer. Pause the screen and try. So you will get the answer as C. Next question. If the temperature of a patient is 40 degrees Celsius, is the temperature on Fahrenheit scale will be? So given is degree Celsius, asking is Fahrenheit. So you must take the relation between degree Celsius and Fahrenheit. Degree Celsius and Fahrenheit. You must take the relation between degree Fahrenheit and Fahrenheit. Degree Celsius. So here our patient temperature is 40 degrees Celsius. So 40 minus 0 is 40 by 100 is equal to F minus 32 by 180. You know, this 0 get cancelled, this and this cancel, and cross multiply. 18 into 4 is equal to F minus 32. So 2, 20, 72 is equal to F minus 32, or F is equal to 72. If I take it this side, minus becomes plus 32. I think 72 plus 32 is 104. So it is 104 degree Fahrenheit. So 104 degree Fahrenheit is nothing but option D. It's D. Next, if a graph is plotted taking temperature in Fahrenheit along y-axis and corresponding temperature in Celsius along x-axis, it will be a straight line. Then which one of the following? They are asking about intercept. Okay, so three options: first option, second option, and four options are asking about intercept, and third option is said passing through origin. Okay, we have to decide. You know, to obtain the graph, we should know the relation between them. As you know, they are asking graph of Fahrenheit scale and degree Celsius scale. So take the relation C by 100 is equal to F minus 32 by 180. Alright. So this and this get cancelled. We want along y-axis. This F is along y-axis. So take F this side and others on this side. So for my convenience, I take 18 by 10 C is equal to F minus 32, or F can be written as 2 5s are 2 9s are, so 9 by 5 C. If it is and this side minus becomes plus. Okay. So this is the relation between Fahrenheit scale and degree Celsius scale. If you look at this equation, this above equation is similar to equation of straight line y is equal to mx plus c. Here instead of y we have m, instead of m we have 9 by 5, instead of x we have c, instead of intercept we have 30. Then we know that this shows graph is a straight line, which shows a graph is straight line like this. Yeah, it is C. See, we know that C gives intercept, that is positive. It is plus. You know, this is equal to 32. And if you take the slope, this slope is nothing but m, that is 9 by 5. Okay, that is not required here. Today we have to know whether we have intercept on x-axis or y-axis. It's clear that we have intercept on y-axis, that is on positive side. Having a positive intercept on y-axis. And having positive intercept on x-axis, is it true? No. Is it passing through origin? No, it is not passing through origin. Having negative intercept on both axes? No. Okay. So therefore, answer is first one. A is the option. Question number 6. A centigrade and Fahrenheit thermometers are dipped in boiling water. The water temperature is lowered until the Fahrenheit thermometer registered 140 degrees Celsius. What is the fall in temperature registered by the centigrade thermometer? Okay. So this can also be solved by same method. But I want to change the method little bit. I'll change the method little bit. Okay. See, normally we are using 3 scales frequently. One is Celsius scale, another Fahrenheit scale, third one is Kelvin scale. Degree Celsius, Fahrenheit and Kelvin. Okay, see, I'll take a lower fixed point. Upper fixed point. It is lower fixed point. Okay. See here to here. In case of degree Celsius scale, there are 100 divisions. All are divided by 100. Okay. And in case of Fahrenheit scale, in this length, there are 180 divisions. In case of Kelvin scale, here there are 100. It is Kelvin scale. It is degree Fahrenheit. It means for a given amount of heat, in all 3 cases, amount of heat remains same. For that, I can say 100 degree Celsius is equal to 180 degree Fahrenheit. whenever we provide certain amount of heat, if there is a change in 100 degrees Celsius, then there is change in 180 degree Fahrenheit and also 100 Kelvin. For a given amount of heat, change in 100 degrees Celsius is equal to change in 180 degree Fahrenheit and 100 Kelvin. If I divide all by 100, then for amount of heat energy required to change 1 degree Celsius is equal to 1.8 degree Fahrenheit or 1 degree. This is very important. That is amount of heat required to change 1 degree Celsius, 1.8 degree Fahrenheit and 1 Kelvin are same. Okay, that is important point to be remembered. That is whenever there is, in another word I can say, whenever there is 1 degree Celsius change in temperature. In degree Celsius scale, if there is change of 1 degree Celsius, then in Fahrenheit scale it changes by 1.8 degree. On Kelvin scale it changes by 1 Kelvin. From this it is clear that change in degree Celsius and change in Kelvin are same. If I say 1 degree, that's a 10 degree Celsius change in temperature. It is similar to 10 degree, 10 Kelvin change. If I say 30 degrees Celsius change, then there is 30 Kelvin change. Means change in temperature in Kelvins, degree Celsius scale and Kelvin are same. Based on this, I can say it's clearly here the centigrade and Fahrenheit thermometers are dipped in boiling water. The water temperature is lowered until Fahrenheit thermometer registered 140 degree. It should be Fahrenheit. Sorry, it should be Fahrenheit. Then what is the fall in temperature registered by the centigrade thermometer? It's very simple. As you know, for 1 degree Celsius, there is a change of 1.8 degree Fahrenheit. Today I want 140 degree Fahrenheit change. For that, how much degree Celsius is changed? Okay, say if I say yes, then x equal to cross multiply. It is 140 into 1 is 140 divided by 1.2 or multiply divided by 10 is 1400 divided by 18 is the answer. Please simplify, you get your answer. Pause the screen and try. So answer is 40 degree. Got it? Okay, 6th question. Next 7th question. On a new scale temperature which is linear called W scale, the freezing and boiling points of water are 30 degree W and 239 W respectively. What will be the temperature on new scale corresponding to a temperature of 39 degree Celsius? Okay, here I think there is a small mistake. Instead of 30, make it as 39 W. Okay. So for such problems, you have to write like this. I take the new scale. Lower fixed point is 39 degree W. Upper is 239 W. I repeat, take this as 39. Okay. And on degree Celsius scale, it is 0 degree Celsius. It is 100 degree Celsius. Okay. Today, if there is a 39 degree Celsius, then what is the corresponding temperature is the question. Okay. So for that, to get answers for such questions, use our standard relation. Okay. See first, reading on different scale. Here unknown scale reading, I will take it as W. W minus lower fixed point is 39 divided by upper fixed is 239, lower fixed is 39, minus means it will be is equal to reading on degree Celsius scale is 39 minus lower fixed point is 0 divided by upper fixed point is 100, lower is 0. You subtract, it will be this and this cancels. You multiply, cross multiply that W minus 39 is equal to 2 into 39. So you can simplify yourself. Okay, get the answer. Answer is 4, 117. Send this side, W is equal to 39 into 2, maybe 78 plus 39. 8 plus 9 is 7, carry 1. So like this you have to calculate. Okay. Question number 8. A faulty thermometer has a fixed points marked as 5 and 95. If temperature of the body shown on the Celsius scale is 40 degree, then temperature shown on this faulty thermometer is. Once again our method remains the same. This faulty thermometer is taken as one scale. Okay. Here in faulty thermometer, lower is 5, upper is 95. Then here it is taken as a 40, then it is the orange. So you can take this as X scale. Use the same, get the answer. Reading on this scale is say X minus lower fixed point is 5 divided by upper fixed point is 95 minus lower fixed point is 5. So this is 90 is equal to reading on the Celsius scale is 40 minus 0 divided by. Hope you can simplify to get a value of X. Pause the screen and try. So answer is C, 41 degree here. Next two questions are over. Pause the screen and write down the problems and take these are the answers. Pause the screen and write down. This is first homework, question number 9. This is the second homework. Okay, pause the screen and write down. It must be T suffix A, it is T suffix B. That is T suffix A and T suffix B. It is a T, it should be suffix A, it should be suffix B. Okay. So this is our first class on thermal properties of matter. This is the first time I am using this projector. Please comment, okay, whether you are feeling comfortable or not. If you are feeling comfortable, I will continue with this method, or otherwise I will try with my previous